We now use differentials to approximate the square root and the cube root of the following. So first let's consider the square root of 49.09. So we have to approximate this using differentials. Since we have to find the square root, we consider the function as f of x equal to square root of x. We then find its derivative by differentiating both sides with respect to x. So when we differentiate the root x, this is basically x power 1 by 2. And when we apply the power rule, we'll be getting 1 by 2 x power negative 1 by 2, and which is equal to 1 by 2 root x. So this is what we get for f prime of x, which is the derivative of f of x. Now considering 49.09, in this we consider x equal to 49. If we say x equal to 49, then 49.09, that is the change in x delta x, or we can write down this as dx. This is equal to 0.09. Okay, and if x equal to 49, this implies y equal to square root of 49, which is 7. Then we will have to find out dy. We can find dy using this formula, that is the differential dy is given by f prime of x times dx. So let's substitute the f prime of x. This is equal to 1 by 2 root x times of dx is 0.09. Now let's substitute the x equal to 49 in this. So this will be 1 by 2 times of square root of 49 multiplied by 0.09. So this is equivalent to 0.09 divided by 2 times of square root of 49 is 7. So it's basically 0.09 divided by 14. You can plug this into the calculator and we get 0.00642. So this is approximately 0.0064. We can restrict to 4 decimal places. So this is basically dy. So we have a dy equal to 0.0064. Therefore, the new y, we can write down this new y as the y, initial value of y plus change in y, that is dy, which is 0.0064. So when we add these two, we get 7.0064. So this new y is basically the square root of 49.09. Let's now use the similar approach to approximate the value of square root of 48.95. We are doing this. So in this, can just make some changes over here. This is 48.95, and so therefore we can consider, can remove this, and I can put this as 48.95. I can consider x as 49, but dx will be different because it is 48.95 minus 49, and this will be negative 0.05. This is negative 0.05. So the y is still 7, but we have to find dy. So all this remains the same. F of x is still again the square root function, and this derivative also is f prime of x, which is 1 by 2 root x. So we get to this stage 1 by 2 root x times of dx, but we have to replace the dx as negative 0.05. This is the only change that we have to do. So therefore, I can remove this. So we are into this stage. We get minus of 0.05 divided by 2 times of x is still 49. So square root of 49 will be 7. So we have to plug this into the calculator. That is minus 0.05 divided by 14. This is negative 0.0035. Negative 0.003, and when we approximate to 4 decimals, it is 36. So this is what we get for dy. So we can come back to here and update this as negative 0.0036. So therefore the new value of yr, which is the square root of 48.95, is 7 minus, can remove this. This is basically 7 minus 0.0036. 0.0036. So this comes out to be 6.9964. Can remove this. The answer for this one is 6.9964. So this is basically the square root of 48.95 using differentials. Let's now approximate the cube root of 27.03, this one, using differentials. So let me completely remove this because this is a little bit different. Here, this time we are going to find the cube root of 27.03. So the function and dy, everything is changing. So we can start over. We say that f of x equal to cube root of x. Therefore, f prime of x, which is the derivative of f of x, is this is x power 1 by 3. We can write down this as x power 1 by 3. When we use the power rule, it will be 1 by 3 x power 1 by 3 minus 1, which is negative 2 by 3. So this we can write down this as 1 by 3 x power 2 by 3. So therefore this is equal to 1 by 3 x squared cube root. In fact, we can rewrite this in a different form as, I'm going to rewrite this a little bit different. This could be written as 1 by 3 cube root of x quantity square. Can write down like this. So let's have it like this. Now we find dy. I can write down dy over here. So dy is given by the formula f prime of x times dx. We substitute the f prime of x, which is 1 by 3 cube root of x quantity squared times dx. We know that the dx, if we consider x equal to in 27.03, cube root of 27.03, we can consider x equal to 27. Therefore, dx is 0.03. And similarly, y equal to cube root of 27 is 3. We are actually finding dy. So this is what we are finding over here. So therefore, we can plug in x equal to 27 and dx equal to 0.03 over here, which then becomes cube root of 27 quantity square times of 0.03. 0.03. So cube root of 27 is 3. And 3 square is 9. 9 times 3 is 27. So this is basically 0.03 divided by 27. And when we plug this into the calculator, we get 0.0011. So this is the dy. Therefore, the new y, which is basically the cube root of 27.03, this is equal to the original y, which is 3, plus dy, which is 0.0011. 0.0011. So therefore, this comes out to be 3.0011. So this is the approximate value of cube root of 27.03. Now, using the same approximation, we can find the cube root of 26.91. So we have to make a few changes over here. This is cube root of 26.91. and therefore x remains 27. However, dx will be 26.91 minus 27, and this is equal to negative 0.09. So I need to erase this and put this as negative 0.09. This is equal to negative 0.09. Once again, y is 3, because cube root of 27 is 3. We have to find the dy. We can come back to over here. Everything remains the same except this dx. We will remove this dx and put the new dx over here. So this is equal to minus 0.09, which means we have to find the new dy. I can remove this. This new dy, this term we are going to get in terms of negative. So this is equal to minus 0.09 divided by 27. You can plug this into the calculator and we'll be getting minus 0.0033, minus 0.0033. So we just have to add this to the y. Therefore, the cube root of, can remove this completely, 26.9y. This is equal to the y plus dy. dy is negative, so therefore this is going to be 3 minus 0.0033, and this is equal to 2.9967. So this is the approximate value of cube root of 26.91 using differentials. This is how we find the square root and cube root of any number using differentials.